We're going to talk about 2.4, solving linear equations. Let's go to work. Solving means isolate. A lot of times we see the word solve and we think we need to come up with a number. That's not what solving means. I say solve, you say isolate. Solve. Solve. I say isolate, you say solve. Isolate. Isolate. So solving equations is all about isolating the variable that we want to get by itself. Okay? How do we solve equations? Well, we solve them by using inverse operations. In all technicality, there's only 4 operations we're going to be dealing with now. Some people might argue that there's only 4 operations in math anyhow. The operations are addition, subtraction, multiplication, and division. Now, if we wanted to get technical, I could probably make the argument that there's actually only one operation, and that's addition. What? Well, what is multiplication? Multiplication is just repeated addition, right? 3 plus 3 plus 3 plus 3 is really 3 times 4. Get it? I could argue that, so multiplication is addition, right? Just repeated addition. I could argue that subtraction is just really adding negative numbers, right? And then, well, what about division? How could division be considered addition? Well, division is really multiplication by a reciprocal. We've already said multiplication is just a repeated addition, right? But we're not going into that. We're just talking about these 4 operations, okay? Think about addition and subtraction as family, multiplication and division as family. Not only are they family, but they are inverse operations. I say inverse, you say opposite. Inverse. Inverse. I say opposite, you say inverse. Opposite. Opposite. Inverse operations are opposite operations, or they undo each other. For example, all of you have something in your pocket. I don't know what you have. We're going to call that X. Today is your lucky day. Yep, here's my wallet. I'm going to give each of you $20. So whatever you have, plus 20. However, as soon as I give you that $20, I am then going to subtract $20 from you. So what did I really give you? Nothing. You're left with what you started with, right? So giving 20 and taking 20 away, they're inverses. They're opposite. But don't say I didn't ever give you anything because I just gave each of you $20. And then we'll just leave off the part that I took it back. Okay? All right. And that's how we're going to solve equations, is by using the inverse operations. So in order to solve equations, we just got to see the operations being performed and use the inverse or opposite. I'm going to start with simple equations and work my way up. When I say simple, I mean one-step equations. For example, here I have x plus 4 divided by 12. Now, many of you probably put this line down there to kind of think of a balance, and we want to balance the equation. Yes, you've done that in the past. If you like that, you can continue to do it. I don't necessarily do it. I'm going to do it today, but after that, I may not use that line ever again. I hope that's okay with you, because I'm going to show you things, and then I'm going to expect you to get really fast at it. Okay? One other thing I like to tell my students a lot of times is, how do I know if I'm going to move the 4 or the 12? Well, a lot of times I would have my students put their hand over the variable. And then whatever's there with your hand, in this case would be the plus 4, that's what I'm going to deal with. That's what I'm going to move, okay, or get rid of. And I move it by using the inverse. So that's a plus 4. Inverse would be minus 4. Whatever I do to one side, I got to do to the other, so minus 4. So I'm left with, the 4's cancel on the left. I'm left with x equals negative 12 plus a negative 4, or negative 12 minus 4 is a negative 16. I know this is very simple. I got it, but we're going to move kind of quick, okay? What if we have a subtraction problem? The opposite of minus 9 is plus 9, or the inverse. Whatever I do to one side, I do to the other. By the way, this whatever I do to one side, I do to the other. Those are properties. They're properties that tell me I can do this. You know, the property, the addition property of equality, the subtraction property of equality. They say, hey, if you add 9 to one side, you can do it to the other, and we keep our scales balanced, right? I know that you've learned that in the past. So here I'm left with m equals 19. What if I have a multiplication problem? 3 times n. Inverse of multiplication is division. So I would divide by a negative 3. Whatever I do to one side, I do to the other. So n equals 9. Simple enough, doing okay. Last type of problem we might have would be division. What's the inverse of division? Multiplication. So 9 times 9 cancels, and then times 9 on the other side. 3 times 9 is 27 equals n. Now here's the cool thing. Oops, n, not 9. Here's the cool thing I like about equations is when you get an answer, you don't even need an answer key. Why not? Because when you're finished, you can take that answer and plug it back into the original problem and see if it's true. For example, let's look at number 1. Negative 16 plus 4. Does that equal negative 12? Yes, it does. So I'm good. Looking at number 2. Is 19 minus 9 equal 10? Yes, I know I got the right answer. Negative 3 times 9. Does that equal negative 27? Yes, I got the right answer. Number 4 is 27 divided by 9 equal to 3. Yes, I got the right answer. So we don't even actually need an answer key. We can just plug it back in, solve. Those are simple one step. Just to remind you that we basically have 4 operations. You see one operation, do the inverse or the opposite. What happens when we have multi-step equations? Okay, multi-step could be a couple different things. First, we could have 2 variables on the same side. Anytime that we have multiple variables on one side, we want to start with CLT. No, that's not a bacon, lettuce, and tomato sandwich, which would be kind of good right now. That is combine like terms. Okay, combine like terms. Well, what are like terms? Not similar. It's the same variable or variables to the same power. We're only going to be dealing with single variables right now, so I'm just going to say same variable, same power. For example, can I put together an x squared and an x? No, it's the same variable, but it's not the same power. Can I put together a x squared and a y squared? No, they're different variables. Might be the same power, but they're different variables. In order for things to be like terms, they got to be the same variable to the same power. Here I have an n and an n. I can put those together. Negative 2 plus 4 is a negative 6. Oops, I'm sorry. Is a 2n equals 0. Now that I've combined them, I'm back to a one-step equation, right? That's 2 times n, so I'll do the opposite of times, which is divide. 0 divided by 2 is 0. Cool. Let's look at this 11th one here. I can start off. I see those 2 like terms. I want to start by combining them. Negative 11 equals 1 minus 4x. It's a negative 1x, right? And a negative 3x. Put those together, I get a negative 4x. Now I'm down to a two-step equation. I got to isolate this variable. What does isolate mean? Get it by itself. I'm going to solve for this x. So what do I have to move? Well, remember, I said the best thing you can do is cover up that variable. What's with it? A positive 1. I want you to look at this. Eyes up here on the screen. Notice that when I covered this thing up, I covered all that up, right? See, this negative sign goes with that 4x, doesn't it? Some people would see this subtraction problem and think we have to add 1 because it's a subtraction problem. But that's not. This sign goes with that term. So as I cover that up, I cover up that sign as well. So what do I got to do to that 1? I got to subtract it because it's a positive 1, even though there's not a sign there. You understand that? Does that make sense? I hope so. Whatever I do to one side, I do to the other. So now negative 12 equals negative 4x. Now I have multiplication, so I must do the opposite, which is divide by a negative 4. That sign goes with the number, right? Divide by a negative 4. So 3 equals x. How would I check? Plug it back in. To the original? Sure. Negative 11 equals 1 minus 3 times 3. So negative 11 equals negative 11. It works. Cool. Now, I do want to make this statement, okay? Here we have variables on both sides. When I have variables on both sides, I can't just combine them. I have to move them across that equal sign. And anytime that we're going across the equal sign, that's when we're using our inverses, right? Right. So you can do what you want, but please do this for me. Always deal with your smallest variable first. Every year, as long as I've been teaching, people who deal with the numbers first because they know what the numbers are always seem to be struggle more than students who deal with their variables first, okay? So let me find one that has variables on both sides and nothing else. Yeah, this one. Quickly, I'm just going to combine those two like terms. So I got 2 plus 6n equals 2n plus 10. Everybody okay with that? Cool. I need to move one of those variables. If you always move the smaller one first, 90+% of the time you'll end up with a positive number, so versus a negative. And we all know we struggle with our negatives sometimes, right? So I want to subtract 2n first from both sides. Now I'm left with 2 plus 4n equals 10. Why did I move the 2n? Because it's smaller. And I always deal with the variables first. Now I have the same type of problem that we've been working with. Okay, cover up my variable. So I'm going to subtract 2 minus 2. 4n equals, sorry, that was an equal sign, equals 8. Divide by 4, n equals 4. Say again. Thank you. 2. My bad. N equals 2. I like it that you caught that. Questions? Seems easy. Okay. I'm going to stop putting some of the work down. Stay with me. See the distribution of a negative 1? Negative x plus 4 equals 4x plus 14. I would then move the smaller variable. 4 equals 5x plus 14. Get the variable by itself. Negative 10 equals 5x. Use the inverse of multiplication. Negative 2 equals x. Now there, I didn't necessarily write down what I did I? Can you follow it? Plus x, right? What do I do in the next step? Subtracted 14, right? Then what? Divided by 5. Cool. I want you to be able to see those steps without me having to necessarily write them down. All right. We're going to spend some time on this, but regardless, solving means isolate the variable by using the inverse or opposite operations, and then we check our work by plugging the solution back in. Okay? All right. We've got some work for you on your Google Classroom. Have a great day.